Hello, welcome to week 5, which is on confidence interval, part 2. So the outline for this video lecture is as follows. Confidence interval for 2 matched samples with a continuous outcome, and confidence interval for 2 independent samples for dichotomous outcome. First, we talked about matched samples, also called paired samples or dependent samples. They are samples in which there is a one-to-one correspondence between each and every member in the 2 samples. And 2 typical study designs lead to matched samples are the pre- and post-test design and 2, the matched case control design. Okay, we talked about this briefly in lecture 1. We discussed the importance of study design in determining the appropriate statistical tests for analyzing the data. Okay. For matched samples, to calculate a confidence interval for the mean difference, we can simply compute the differences of the matched pairs and then compute a one-sample Z confidence interval or T confidence interval depending on the sample size for the differences. So basically, a matched pairs confidence interval is really just we converted it into a one-sample problem. The formula for the mean differences of 2 matched samples, it can be found on table 612 on page 111. Also on the right-hand side, you can see a formula. So you got the D bar, that's the sample mean difference, plus minus T alpha over 2, that's the percentile for the T distribution for the confidence level of alpha. And it's a 2-sided confidence interval. And SD is the sample standard deviation, and N is the sample size. In SPSS, we can compute the T confidence interval for the mean difference of 2 matched samples by using the paired t-test module. And the T confidence interval is contained in its outputs. So basically, we can just click Analyze and select Compare Means and then select Paired t-test as shown on the image on the right-hand side. And I also provided the link to a YouTube video about how you can actually perform the one-sample t-test for matched samples. And then as a result, you can actually get the confidence interval, from its outputs. And the second topic is confidence interval for 2 independent samples, but with a dichotomous outcome. Okay, so dichotomous outcome are more complicated. For measures of association or measures of effect, we have discussed several metrics. One is called the risk difference. So it's simply the difference between 2 proportions. Or we can say we have relative risk, which is a ratio of 2 proportions. And of course, we have another commonly used metric called the odds ratio. Okay, so we're going to go through confidence intervals for these 3 different types of risk measure for dichotomous outcomes. First, for risk difference, okay, the formula for the risk difference is shown on the right-hand side, and also you can see it in table 617 on page 114. So if you look on the right-hand side, you can see RD, that's the risk difference. So it's it equals to P1 minus P2, where P1 and P2 are the true population um, proportions. And then with a sample, we can actually estimate that. So RD hat equal to P1 hat minus P2 hat. So these are the sample proportions. And then the confidence interval for the risk difference is provided in that formula. And you can see the percentile Z, that's from the standard normal distribution. So this is actually a Z interval, which means we are using an approximation of a normal distribution to the dichotomous variable distributions. Okay, so in table 617 on page 114, please read carefully the assumptions of this formula. Okay, the formula is not accurate if the assumptions are not met. Okay, so they're really important. If the assumptions are not met by the data, you should not use this formula. So even though we have the formula for the risk difference confidence interval, unfortunately, there's no SPSS module that delivers the interval for the risk difference. And we have to use some programming using SPSS syntax. But that's beyond the scope of our introductory course. So I'll just mention it. And also I have provided a link to an online calculator from Varsa Stats. It asks for some sample proportions, sample size, and then it will compute the confidence interval for the risk difference for you, so that you don't have to use calculator and use this formula to manually compute the confidence interval. Okay, and for relative risk, the formula is on the right-hand side. It can be found also in table 620 on page 116, so please review that. So the relative risk is basically the ratio of two proportions, and then we can actually first calculate a confidence interval for the logarithm of this risk ratio, and the one of the formula is shown here. I think the formula in our textbook looks a little bit different because they use the sample counts and the sample size instead of these P1 hat, P2 hat, which are sample proportions. Okay, but when you use these formula, please remember that at the end you need to exponentiate the confidence limits of the log relative risk to get the confidence interval for the relative risk. Okay, so you have to take the exponentials of the confidence limits. Confidence intervals for both relative risk and OR can be obtained by using the SPSS crosstab module after summarizing the counts into a weighted crosstab format. So you can use analyze descriptive statistics and crosstab, and then the data must be put in crosstab format. You cannot use the raw counts. Okay, and I also have provided a link to a YouTube video about how you can compute confidence interval for RR and OR using the crosstab format of the data set. And of course, I will provide a step-by-step instruction for showing how to do this, and a video. So odds ratio is another metric for the association of association between exposure and disease, and it is a preferred measure because it has good properties, such as you can use the same formula to calculate the odds ratio estimate from a 2x2 table, regardless whether the study design is a cohort study or it is a case control study. Okay, so OR is a pretty well-known metric for association. And the formula for a confidence interval of OR in a 2x2 table can be found in table 621 on page 117. And also you can find a representation here on the right-hand side. So you can see an estimate for the OR using the sample proportions. And then you can calculate a confidence interval for the log OR using that formula log OR plus minus Z off over 2, then square root 1 over A plus 1 over B plus 1 over C plus 1 over D, where A, B, C, D are the cell counts in that 2x2 table. Okay, and this formula is also called the Wolf confidence interval for odds ratio. And also here's a note. Please pay attention that you should exponentiate the confidence limits of the log OR to get the confidence interval for the OR. And the procedure for calculating confidence interval for the OR is the same as that for the RR, the risk ratio. Okay, and the video is the same as well. Using the same procedure, you can get confidence interval for both. And in this video, it is shown steps how to get the confidence intervals.